Hi my dear friends, welcome back to your channel of learning mathematics. Today is a special, I'm going to do a special video for the class 10 students. As the NBSE has provided the question bank for class 10, 11 and 12, I will be solving today the question bank for class 10. I've already done that for 11, and I've already done a part for class 12. Now I'm doing this for class 10 students. So I believe and I hope that this will prove to be very beneficial for you. So without further ado, please take out your pen, book, papers, textbooks, and I do believe that you have your question bank with you, which the NBSE has provided. So if not, I will, of course, it will take quite a time, but I will be writing down the questions also, just in case some of you are unable to take out the printouts or download the question bank provided by the NBSE in their official website. So you can just check it out from there also. So I'll be starting off with the 3-mark questions, and please give importance to the question bank also. It will help you very much in practice, and I guess I can't say if you're very lucky. So please go through the question bank, because to be honest, it provides an overall revision for the entire syllabus, so it will prove to be very beneficial. Some of the questions are from the reduced portion, so that we will not be doing. Okay, we will be skipping that part. Alright then, so let's start and see how many questions we can do in the first session. So as I've written section C, that is the 3-mark questions. The first question states, if alpha and beta are the zeros of the quadratic polynomial 2x squared minus 5x, given polynomial is 2x squared minus 5x plus 7, then find the quadratic polynomial whose zeros are this. The zeros of the given polynomial are alpha and beta. So we are supposed to find out another new polynomial whose zeros are given by 3 alpha and this 3 alpha plus 4 beta and 4 alpha plus 3 beta. So that's why they give us this condition that this polynomial and its zeros are alpha and beta, because the new zeros that we have are linked with alphas and betas. So definitely there must be a reason why they've given us the zeros to be alpha and beta. So we will definitely they want you to use this condition, so we will see what can be done. Now since this is a revision part, examinations are fast approaching. I believe that you are all done with the syllabus, at least a little bit, so I will not be sticking too much into the detailed explanation and all. So I'll just go for focus on basically solving the problems only. Okay, so not the conceptual things. So as I will assume that most of you know at least something. Alright, so as we know, if we compare this quadratic polynomial, okay, I'll just write down, otherwise some of us might be confused. Comparing the given polynomial with our standard quadratic polynomial ax squared plus bx plus c. If we compare this two, then our value of a is 2, the value of b is minus 5, and the value of c is 7. So as we know that sum of zeros is actually what? Minus b by, sum of zeros is minus b by a. So alright, I will wrap up the question. Sum of zeros is equal to minus b by a. So what are our zeros for this polynomial? Alpha and beta. My value of b is minus 5 by a, that is 2. Remember, it is minus of b by a. The value of b is already minus 5, so that's minus of minus 5 by a. So that means the value of our alpha plus beta is 5 by 2. So this is what we have. Beyond this we cannot solve. So, but definitely I believe that we will be requiring this condition. So let's see, we'll mark that as equation 1. And product of zeros is given by c by a. So product of zeros means alpha into beta. The value of c is 7 by a, 7 by 2. So these are the informations that we can derive from the question. So now, what are our new zeros? The new zeros are 3 alpha plus 4 beta and 4 alpha plus 3 beta. So using these two new zeros, we are supposed to find out the new quadratic polynomial. So for that, definitely what? We will need sum of the new zeros. So sum of the new zeros, that is 3 alpha plus 4 beta, this is 1 0, plus the other 0. So if we just, since this is all addition, 3 alpha plus 4 alpha, I'll save some time by skipping some steps for 7 beta. So that will be of course 7 of alpha plus beta. 7 of alpha plus beta. So as we know, I'll just do it here, is equal to 7. Alpha plus beta, that's the information that they want us to use. That's 5 by 2. So that will be of course 35 by 2. So this is the sum of the new zeros. Alright. And product will be 3 alpha plus 4 beta plus 4 alpha plus 3 beta into 7 by 2. Let's not forget that. So now we'll go for the product. 3 4s are 12, alpha square plus 3 3s are 9, alpha beta plus 4 4s are 16, alpha beta plus 4 3s are 12, beta square 12 12. I'll bring this together. 9 plus 16, 25. I guess you're done. You can pause the video here and you can write down. So 12 common, alpha square plus beta square plus 25 alpha beta. Now what happens here is we do not have any information regarding alpha square plus beta square. We have the information with respect to alpha plus beta and alpha into beta. So how do we convert this so that we can use the information given to us? Something like this can be done, because we know from algebraic identities that a square plus b square is a plus b whole square minus 2ab. Now since a plus b is the information given, a into b is the information given, I will convert that. So 12 of, this one can be written as alpha plus beta whole square minus twice of alpha beta plus 25 alpha beta. Now let's substitute our values. Alpha plus beta was 5 by 2 whole square minus twice of alpha into beta, if I'm not mistaken it was 7 by 2, 25 7 by 2. So let's simplify this. 12, 25 by 4 minus 14 by 2 plus 7 5 is 35, 3 left, 7 is 14, 15, 16, 17 by 2. 12 into, if we just take the LCM, 4, so 25 minus 14 into 2. I'm not cancelling. If possible, I will cancel it in the last. So, okay, 4 1s are 4, 4 3s are 12. So 3 into 25 minus 28 plus 175 by 2. So that's going to be 3 into minus 3 plus 175 by 2. So that's like minus 9 plus 175 by 2. So again taking LCM, 2 minus 9 means 9 by 1. So 2 1s are 2. So 18 plus 175. So you can just check out how much do you get from there. 8, 7, 1, 2, 3, 4, 5, 6, 157 by 2. So this is the product of the zeros. So you can note down, pause the video and you can note down there. So now we have the sum of the zeros and the product of the zeros. So I'm sure that all of us know how to find out the required polynomial. That's why we found out the zeros and the product. The required polynomial is p of x equal to x square minus sx plus p, where s represents the sum of the new zeros, p represents the product of the zeros. S represents sum of the zeros and p represents. So the required polynomial will be given by x square minus sx plus p, where s is the sum of the zeros and p is the product of the zeros. So that's x square minus sum was 35 by 2x plus product is 157 by 2. So of course you can take 2 as the LCM. We'll have 2x square minus 35x plus 157. So 1 by 2, 2x square minus 35x plus 157. So this is the sum of the required polynomial. Of course in the textbook it might look slightly different, like this 1 by 2 might not be there, but only this, they might have given to you only this polynomial. It's all the same, don't worry about that, okay, because another format is k into x square minus sx plus p, so it's all the same, so don't really bother about that. K is 1 by 2 here, alright. So they just give you the polynomial only, this one, 2x square minus 35x plus 157. Alright, so it's not a big deal. This will be fine, perfectly fine, don't worry, trust me. Alright, so that's it with the first question. So let's move on to the next question. Question number 2. I'll write down the question as I promised. It is given that 1 is a zero of the polynomial 7x minus x cubed minus 6. Find the other zeros. Since this is a cubic polynomial of power 3, it will have actually how many zeros? 3 zeros. 1 0 they are already giving it to us. So we are supposed to find out how many zeros? 2 more zeros. Alright. So of course this type of question was done in class 9 also. Okay, but anyway, let's get to the point. Straight solution. Since the variable is x, I'll consider given x equal to 1, isn't it, is a 0 of the given polynomial. I'll just rearrange that, minus x cubed plus 7x minus 6. So given that x equal to 1 is a 0 of the given polynomial, by arranging it, minus x square plus 7x minus 6, which implies that x minus 1 is a factor of the given polynomial. This one you already know that from class 9 also. So if x equal to 1, then x minus 1 is a factor of the given polynomial. If you remember, remainder theorem, factor theorem, right? So that's it. So now we will divide, and because we will be using the division algorithm, I'll just show it to you here. And if you wish, you can write. If you don't wish, no need to write this one. We know that, okay, I'll just write down. Dividend is equal to divisor into quotient plus remainder. So we're going to use this concept. Class 9 we have already done this. Alright, so I'm going to rub this off now, because next, since we already have one factor, the other way to solve and get the other two zeros would be to divide. So now, since we already have one of the factors, what we will do is we will divide our polynomial minus x cubed plus 7x minus 6 by the factor which is given to us in the question. So minus x cubed plus 7x minus 6. So let's do the division. I guess division all of us minus, so minus, well, multiply minus x squared. So minus x squared minus x cubed. 1 into x squared, that's x squared, minus into minus, that's plus. So by subtracting, the sign changes, minus plus out. This is a new term, minus x squared. I'll bring this, because I cannot equate my x squared and 7x, different terms, minus 6. So again, minus minus x. So that's minus x square minus minus plus x. So that's plus minus 7 minus 1, that's 6x minus 6. So multiplying by 6 factor, 6x minus 6. Subtracting again, as perfectly mentioned, since it was already given in the question that x minus 1 is a factor of the given polynomial, that's why our remainder is also 0. If the remainder is not 0, then only there will be some problem. Okay. So therefore, our given polynomial can be written as what? That is a dividend, isn't it? Dividend is equal to what? Divisor into quotient minus x square minus x plus 6 plus remainder. Remainder is what? 0. So now we're supposed to find out the zeros, isn't it? So for that we'll have to find out the factors. So let's use splitting the middle term. I've done a video on splitting the middle term. You can just go and check that out also for factorization. So minus x square 6, 3 2s are 6. So that's minus 3x plus 2x plus 6. So that's going to be x minus 1 minus x common. So I'll have x plus 3 plus 2 common from here. I'll have x plus 3. Same terms. Again common. X minus 1 x plus 3 minus x plus 2. So these are our two other factors. So from the factors, as we have seen in the beginning of this question, we can get the zeros. From the zeros we can get the factors. From the factors we can get the zeros. So therefore the other two zeros are x plus 3 equal to 0, that is x equal to minus 3, and minus x plus 2 equal to 0, that is minus x is equal to minus 2, minus minus cancels, x equal to 2. So our other two zeros are x equal to 2 and x equal to minus 3. Alright, I believe that's perfectly fine. Okay, so you can pause the video here, you can write down. Alright, so let's move to the next question. Next question is from chapter 3. That's the substitution method. Question number 3. I'll just write in short. Solve by substitution method. Our equations are s minus t equal to 3 equal to 6. We will name this as equation 1, equation 2. So I believe all of us we are familiar with substitution. Let's begin. From equation 1, s minus t equal to 3. So you can substitute one of the values. So I'll do it for s, that I'll mark it as equation 3. Substituting T-I-T-U-T-I-N-G. Substituting value of s from 3 in equation 2. So what is the value of s? In place of s, I will replace by 3 plus t. So I'll have 3 plus t divided by 3 plus, the other values will remain, will not change. It is not supposed to change, substitution only. So I can take the common LCM, 3 2s are 6. So 3 plus t into 3 2s are 6 plus t into 2 3s are 6 is equal to 6. So multiplying 2 3s are 6, 2 plus t. 2t plus 3t is equal to 6 into 6 by cross multiplying these two values. So that's like 6 plus 5t is equal to 36. So or 5t is equal to 36 minus 6. 5t is equal to 30. T is equal to 30 by 5. So 5 6 are 30. So the value of t we get what? 6. Alright, so that's it. Almost done. So now finally putting t equal to 6 in equation 3, from where we will get the value of s. 3 plus 6, that is 9. So therefore s is 9, t is 6. Alright? Okay. Next question. The next question is slightly off a part of the reduced syllabus, but I will just do it. Question number 4. This is solve by cross multiplication method. So if you are not interested in this particular question, you can just skip to the next, skip the video, so you can just go to the next question, but I'll just solve this particular question, okay? Because these are good questions, it's just that it has been removed. 3x minus 3y minus 15 equal to 0. So I'll just do this quickly. 1, 2. So the coefficients, I'll just write down the coefficients here. A1, A2, B1, B2, C1, C2. But this is a very important method. So later on you can just try to learn this also. Okay, it will help you. Minus 3, minus 7, minus 15. So by cross, I'll just write in short multiplication. Variables are x, y, 1. So the formula is very simple to remember. I'll start with B. B1, B2, C1, C2, A1, A2, B1, B2. So the coefficients are, if you just write this, and then we just use to cross multiply. B1, C2. I'll just give it a formula. B1 C2 minus cross multiply B2 C1. Similarly, we'll continue. C1 A2 minus C2 A1, and then again A1 B2 minus A2 B1. This is the formula. So if we just write down the coefficients, we have B1 minus 3 minus 3 minus 7 minus 15, 1, 3 minus 3 minus 3. So we're going to do the cross multiplication using the formula. That's why it's called cross multiplication. So that's going to be x equal to minus 3 minus 15 minus 3 minus 7 y by minus 7 3 minus 1 15 equal to, I'll just rub this off, not necessary now, 1 by 1 into minus 3 into minus 3. So that's going to be x by 45 minus 21, y by minus 21 plus 15, 1 by minus 3 plus 9. So that's x by 24, y by minus 6, 1 by 6. So therefore x by 24 is equal to 1 by 6, and y by minus 6 is equal to 1 by 6. So x is equal to 24 by 6, that is 4. Y equal to minus 6 by 6, that is minus 1. So the value of x is 4 and the value of y is minus 1. Alright, so this was the cross multiplication method. Okay, you can pause, and if you wish you can write out just for practice. If you don't want to take any risks. Of course it's reduced, so definitely it is reduced. So as I said, those not interested of course could easily skip to the next question. That is number 5, that's from chapter 4. This is by, I'll just write in short, completing the square, by completing the square method. Okay, I'll just write on the question properly, but some of you might be confused from where did I get this question, isn't it? So find the roots of the quadratic equation 2x squared plus x minus 4 by method of completing the squares. So I've done this video. Equal to 0. Actually, I've done this video, a special video on completing the squares, so you can just go and check out that particular video also. Alright, so completing the square means we will try to, so in that video I can give you the link below. It is very clearly explained what to do and what not to do. I will try to do that explanation in brief once again. So we're going to complete. So as I mentioned, this coefficient should be 1, possibly, that's much better. So I'll divide all the terms by 2. So that's x squared plus x by 2 minus 2 equal to 0. Now I'll try to complete the square. X square, x whole square plus twice into a into b plus b square minus 2 minus b square is equal to 0. You can just check out the other videos. Here, as I said, I'm just giving you the solution only, because I assume that much of the mathematics part is actually learned by you. So here I'm just giving you the solution only, alright? And here and there I'm trying to give you some concepts also. So adding and subtracting b. Now what should be the value of b? Of course a is x. So what should be the value? So there is a way to find out, that is, I can use 2xy, which is supposed to be, let's say, 2yb is equal to, I should have x by 2. So x cancels. So b will be 1 by 2 into 2. So b should be 1 by 4. That's one way to find out. 1 by 4, 1 by 4. So that means this term is nothing but a plus b, the whole square, minus 2 minus 1 by 16 is equal to 0. So that's x plus 1 by 4 whole square minus common 2 plus 1 by 16 is equal to 0. So x plus 1 by 4 whole square minus 16, 2 by 1, 2 into 16 plus 1. Taking the LCM here is equal to 0. So that's x plus 1 by 4 whole square minus 32 plus 1 by 16 is equal to 0. Again, x plus 1 by 4 whole square minus 33 by 16 equal to 0. Here, as I mentioned in the previous videos on completing the square, we can use this concept also, difference of squares. So you can note down here and pause here and write down the rest. Alright? Okay, I'll just continue. So then that's going to be x plus 1 by 4 the whole square minus 33. I can write it as root over of 33. 16 I can write it as 4 whole square equal to 0, because root 33 whole square is 2, 4 square is 16. I mean root 33 whole square is 33. You know? So I want to convert it in the form of a square minus b square. And then I'll use the formula a plus b into a minus b. So a plus b into a minus b is equal to 0. So either x plus 1 by 4 plus root over of 33 by 4 is equal to 0. So that's x equal to minus 1 by 4 minus root over of 33 by 4. So taking the common LCM 4 minus 1 minus root over of 33. So this is 1 root, or x plus 1 by 4 minus root 33 by 4 is equal to 0. X equal to root of 33 by 4 minus 1 by 4. So again common LCM 4 root of 33 minus 1. So this is the other 0. Root or solution. Okay, let's move on to the next question. Number 6. Determine the arithmetic progression whose third term is 16 and the seventh term exceeds the fifth term by 12. So as we know, we are supposed to find out the arithmetic progression. To find out the arithmetic progression, what do we need? We need the first term and we need the common difference. Let A be the first term and B the common difference. Given third term is 16, so third term can be written as in using the general term equal to 16, so A plus 2D is equal to 16. That's equation 1. I'll just continue here. Okay, better to not mix up. And it also says seventh term exceeds the fifth term by 12. So seventh term can be written as A 7 minus 1 6D, fifth term A plus 5 minus 1 into D plus 12. So that if we further simplify, A plus 6D is equal to A plus 4D plus 12. A cancels, 6D minus 4D is equal to 12. 2D is equal to 12, D is equal to 12 by 2, that is 6. So the value of D we have as 6. So putting D equal to 6 in equation 1. So A plus twice into D is equal to 16. So A plus 12 is equal to 16. A equal to 16 minus 12, that is equal to 4. So what do we have? Therefore, A is equal to 4. D is equal to 6. So what is our first term? 4. Second term, 4 plus common difference. That is 4 plus 6. That is 10. Third term, that is second term, I can just write like first term plus common difference plus common difference. Second term is 10. Common difference is 6. That is 10 plus 6. That is again 16. Fourth term, that is third term plus the common difference. So that is 16 plus 6. That is again 22. So likewise, no need to find for all. Therefore, the AP is like 4, 10, 16, 22, dot, dot, dot. Only 3 dots would be sufficient. Alright, so that's up to question number 6. I do not want to be making the video too long so that it will be boring for you. So all of us, we can take a 10 minutes break, and after that, I'll let you know in the rest of the remaining questions. Again, we will do in the next part, that is part 2. Alright, so till then, I can take a break and just come prepared for the next part. Okay? Alright then, see you. Bye bye. Take care. See you soon.